So what's the next?
I don't know. It's not.
Is it not in YouTube? You're supposed to see the link. Select.
This one now don't cancel.
This one now.
The other one.
So you can't go back to this one.
I can't go back. So let me excellence. I've copied it. Then send it to them.
Are you streaming live now?
I did not turn on this thing. Just
But why will they do like that? It has never done like that before. But is it this one you used to use?
I use them.
You use the other one though?
Which other one?
The other laptop.
Maybe later. Yes. I'm supposed to. This thing load now. Is still waiting.
You want to pin it?
But once
It delivers. Are you connected to your network?
once
Did you set it for 1 hour? Did you set it for 1 hour?
no, I didn't set it for now. I started calling. Okay. Yeah, if you can hear me, let me know. If you can hear me, let me know. We have to wait for others to join in. Good evening again. So sorry, my laptop just went off. Can you hear me? Good evening. If you can hear me, please let me know. Okay, you can hear me. Yeah, so sorry, my laptop went off, so okay, good. Let's wait for others to join in. Okay, thank you. It wasn't network, it was my laptop. My laptop went off. I don't know, suddenly it just went off. Okay, I'm still waiting for us to join in. Let's see. Okay. Okay, very good. So I think I should continue. Oh, that's true. One more person. Please give me a second. Give me a second, please. I just want to be sure everybody's here. Yes, we can continue, of course. Okay, so now just like I mentioned, I said that there is a process for scientific method. So the first one is observation, but scientists, we do not conclude or based on observation. That would be very wrong. So after observation, the next step should be to ask question. That means when you make an observation, you ask yourself, is it really true that black people are wicked? Since you see that the black people are kind of offensive, you ask yourself, is it really true that black people are wicked? Now, if after that you can put an hypothesis. An hypothesis is just making an assumption. You can put it like that. You can say black people are wicked. That is your hypothesis. But you cannot make that a theory. You cannot make that a conclusion until you are very, very sure. Okay? You can't make that a conclusion until you are very, very sure. Okay? So that is very, very important. Don't worry, you can ask your questions when I'm done talking. Okay, so hypothesis. So let's say in the example I gave, the hypothesis is simply that all black people are wicked or all black people are troublesome. Now, but that is just an hypothesis. As a scientist or as a chemist, as a scientist, because you all are scientists, the next thing you must do is to experiment. That means we don't carry out any conclusion without experimenting. We must experiment. We must be able to gather enough black people to know whether it is true if all black people are wicked. That is very, very important. So you must experiment. Then, of course, that experimentation will lead you to data collection. You collect data from all black people. Maybe you want to do the experiment with 1,000 black people, and you collect data. Once you are done with all of that, you can now come to a conclusion. You can now, at the end of your experiment, at the end of your data collection, you can now say something like, no, based on my experiment, I can conclude that all black people are not wicked. Okay? I can conclude that all black people are not wicked. Or after your experiment, you can conclude that all black people are wicked. But you don't make questions. You don't make what is it called now? Without you don't make, what am I saying? You don't make a conclusion without you passing through an experiment. I hope that makes sense. Okay, so That is for that. I hope you understand what I just explained. If you understand me, kindly notify, say yes sir, I understand, yes sir, I understand. If you understand me, say yes sir, I understand. Okay, very good. Very good. I love the responses. Yeah, very good. So I understand clearly. That's very good. Very, very good. Very good. Very good. Oh, good. Okay. So we are done with chapter 1. Now we want to go into chapter 2. Yeah, I'm glad. I can see your responses and I'm impressed. So we are going into chapter 2. So, but this time around, I'm going to write. Yeah. So the first thing we are going to be looking at is matter. Sorry, my pen. Let me work on my pen, please. We are replying both Airtel and MTN. Yes, that's the main one. Give me a second. I'm trying to get my pen ready. My pen. I'm trying to install it again. Please, still trying to install my pen. Okay, while I'm installing my pen, let me talk about matter. Now, matter, M-A-T-T-E-R. You can be writing while I sort out my pen. Okay? So, matter, like we defined earlier, is anything that has weight and occupies space. I'm very, very sure that many of you are familiar with that definition. Okay? Matter is anything that has weight. This is a new chapter now. Matter. Properties of matter. This is a new chapter. Okay? So matter is anything that has weight and occupies space. Then after that, you should know what we call the states of matter. States. S-T-A-T-E-S. The states of matter. Now, matter has 3 major states. Matter can either be a solid or a liquid or a gas? Hear me, matter can either be a solid or a liquid or a gas. Matter has three states. Matter can be a solid or a liquid or a gas. I hope that makes sense. Hello, are you with me? If you understand what I just said now, just let me know. If you understand what I just said, okay, good. So I'm talking about matter. I already said that matter, we've already defined matter before, is anything that has weight. Actually, it should be that has mass and occupies space. Okay, so that leads us to what we call the states of matter. Now, matter has only three states. Okay, the first one is called gas. The second one is called liquid. And the third one is called solid. Now, as you advance, in some other countries, they add a fourth one. But in Nigeria, don't add it though, but I'm just telling you for knowledge sake. They add the fourth one is plasma. We don't really have plasma on Earth. It's usually in space. It's also a state of matter. But as far as chemistry is concerned, and you are a Nigerian student, you only know three states of matter, which is solid, liquid, and gas. Okay? Now, apart from knowing the state of matter, you need to also know what we call the change of states of matter. You need to also know what we call the change of state of matter. Okay? Now, the change of state of matter is simply that matter can, don't worry about plasma, matter can change from one state to another. So you should know what each of those changes mean, and and know what each process is. For example, you have solid here, and I have liquid, and I have gas. Now, solid can change to gas, to liquid. And the process of solid changing to liquid is called melting. The process of liquid changing back to solid is called freezing. The process of liquid to gas is called vaporization. Vaporization. Now we say vaporization, or what we call evaporation. Then you can go from gas back to liquid. That one is called condensation. Okay? Then there is a process of going from solid to gas that is called sublimation. And there is a process of going from gas to solid that is called deposition. Now please, I want to beg you, give me your attention. Give me your attention. Very, very, very very important. Okay? Very, very, very important. Please don't worry about plasma discussion. Okay? Just focus on solid, liquid, and gas. Okay? Now, for like I mentioned, melting means the process of changing from solid to liquid. So you can say something like a solid melts. Then if a liquid is turning to solid, you can say a liquid freezes to become a solid. That's very important for you to note. If a liquid is turning to gas, you say it vaporizes. A liquid is vaporizing to gas. If a gas is changing to liquid, if a gas is converting to liquid, you say the gas has condensed. So it is possible for gas to become a liquid. It is possible for gas to be transformed into a liquid. At that point, you say that the gas has condensed. Then if you are going from solid to gas, you call that sublimation. That means you can say something like, this solid has sublimed, or this solid sublimes. Then if you go from evaporation, if you go from gas back to solid, is deposition. Okay, so a gas can depose to become solid. Now these are the different changes of states of matter. Matter can change from liquid to solid, from liquid to gas, from gas to liquid. The transformation can happen, whichever way, and it is very important that you know. So one thing you should remember is that matter can change from one state to another, and these processes, you should know them. As a matter of fact, there are some questions in WAEC. If you visit WAEC past questions, you will notice that sometimes they can draw a diagram like this. They can draw a diagram like this and ask you to complete it, to name the processes. Very important. Okay, somebody is asking gas to liquid, steam, water, right? Yeah. Not only water. Water is not the only liquid that can turn to gas. But when water turns to gas, let me put it this way. For some of you that don't know, there is a difference between evaporation and vaporization. A little difference. It's the same thing, but there is a little difference. Now, this one called evaporation can happen at any temperature. Evaporation can simply happen at any temperature. But vaporization, you will need to heat water. If I'm using water, for example, you need to heat water until it gets to 100 degrees Celsius. Then it will boil. Water must boil, then it will now begin to vaporize. That means it will now start turning to gas. So even though sometimes we may use the words interchangeably, but they don't mean exactly the same thing. Evaporation can happen whether the water is cold or warm, but vaporization only happens when the water has boiled. Then all the liquid will just change to gas. Now, for some of you that has maybe been in the kitchen before, you could boil drinks. Any liquid can be boiled. Now, for those of you that has boiled water before, maybe you put water on fire. I don't know how careful or how careless you have been, but you put water on fire and you forget that you put water on fire. And by the time you come, you notice that all the water has vaporized, has turned to gas. You don't have any water left. What you have is an ordinary pot. All the water has, that is vaporization. That only happens when water happens, and vaporization happens very fast. Once water boils, if you don't bring the water down immediately, everything is going to vaporize. Everything will move. I hope you understand that. Please let me know if you understand this before I move to the next. Okay, very good. So both evaporation and vaporization means that water is converting to gas. Okay, but the difference is that evaporation can happen at any temperature, but vaporization happens especially when water boils. Okay, when water boils. Okay. Okay, good. Now somebody is saying I should explain the process of condensation, and I will be willing to do that. Now, let me say this. In the case of condensation, some of you must have come out, let's say in the morning, very early in the morning. If you live in an area where you have grasses around or trees around or you have cars, very early in the morning, you will notice some water droplets, you know, on the trees, on the leaves, on car and all of that. You will notice those water droplets. The reason is because if you want gas to become a liquid, there are two things you can do to make gas to become a liquid. One of the things you can do is to reduce the temperature, make it very cold, make the environment very cold. If the environment is cold, the gas in the air will turn to liquid. Let me give you this simple experiment. Bring out a Coke bottle from the fridge, you know, or any very cold drink from fridge. Clean it very well and leave it on the table. After some time, you will notice that water droplets will be on that Coke bottle as if it is sweating. The reason why it is happening like that is because the Coke bottle is very cold. Once cooling happens, the air around it will condense to become liquids. So one of the ways for gas to turn to a liquid is by cooling. You cool it, reduce the temperature. You will see water everywhere. I believe that makes sense. Yeah, I believe that makes a lot of sense. Okay, then another way you can condense, very good, I like your responses. It's making me know that you are following. Ugo Goodness, all gases can turn to liquid, all of them, as long as you give them the right temperature. All gases. And let me say this, for example, you can go to the market now and say, I want to buy oxygen. If they give you oxygen, it's not going to be gas. It's going to be in liquid form. But they will compress it. The second way of turning a gas to become a liquid is by compression, reducing the pressure or increasing the pressure. When you compress gas molecules, it will compress and become a liquid. Now, but I want to say this. All gases, it is dangerous to convert all gases to liquid. Some of them, if you try to convert it, it will explode. There are some gases like that, they will explode. But many other gases, you can have them in liquid form by compressing them. There is a way, there are instrument that is used for compression that can compress the gas to become a liquid. And that liquid now can now be stored. So you go to the hospital, they say they want to give somebody oxygen. But the oxygen is in liquid form. The reason it's in liquid form is that that's the only way they can store it. They can store it in liquid form. it can be carbon dioxide, it can be any gas at all you think. Okay, so for those of you just joining, don't worry, just follow, you will get to understand it. That's why I want to advise you, please don't join late. You are joining by 8 and we started since 7. Okay, so the point I'm trying to make here is that matter can change from one state to another. Yes, cooking gas is an example. Oh, God bless you, Lillian. Cooking gas is an example of gas being stored as a liquid. If you shake it, it's a liquid, but it's actually a gas. And the way you know something that is a gas is a liquid that is a gas is that if you open it, it will just evaporate very easily. It will just, move very easily. So the point I'm making here, don't worry, all of these things are topics in chemistry. We are still going to emphasize them. The point I'm trying to make here is that matter can change from one state to another. Solid can change to a liquid. Liquid can change back to solid. Liquid can change to gas. Gas can change back to liquid. Solid can change to gas. And gas can also change back to solid. And if you notice, I wrote the names there. From solid to liquid, you call that melting. From liquid back to solid, you call that freezing. From liquid to gas, you call that vaporization. From gas back to liquid, you call that condensation. From solid to gas, you call that sublimation. From gas back to solid, you call that deposition. That's the best I can give you now. We are going to still, all these are different topics, so we are going to see them as we continue in chemistry. I hope I am making sense. Okay, so the next thing I want to talk about is that the process of conversion. This is important for you to know. Now, the process of conversion from solid to liquid to gas is done by heating. Heating, H-E-A-T-I-N-G. I have spelt it. Is done by heating. Okay? Now, that means if you heat a solid, it will turn to liquid. Please listen to me. If you heat a solid, it will turn to liquid. If you heat it, it gets to a point, it will turn to a liquid. If you heat a liquid, it gets to a point, it will turn to gas. So heating encourages solid to turn to liquid and to gas. Now, but let me say this. There are some substances, listen, there are some substances that when you heat them, instead of turning to liquid, they turn straight to gas. Some substances, not all. Some substances. For example, have you guys heard of camphor? Have you seen camphor before? Camphor is an example of a solid that turns to gas immediately. Are you with me? My environment is quite dark. You may not see me. Okay? So, camphor is... there is a stand. Okay, so camphor... Okay, some of you have not seen camphor before. You should know camphor. Camphor is, yes, in toilets. God bless you. They use it in toilets. Some people use it to store clothes. Some people use it for, for different purposes. Okay? Now, it is important for you to note that camphor, it is not all solid, but some solid like camphor. Another solid can be iodine. Another solid, you may not know it now, we call it ammonium chloride. Those are special solids. If you heat those solids, they turn to gas straight. They don't turn to liquid, they turn to gas straight. Okay, that's very, very important. Okay, yeah, somebody said to keep rodents away. You know, that's why if you want to enjoy science, make sure you have it around you, you see it around you. Okay, so these are some, that's just an example. Now the process of going from gas to liquid, and let me say this, if you have never seen camphor before, after this class, tell your dad or your mom to go and buy camphor. Yeah, tell your mom or your dad to go and buy camphor. Yes, that's why camphor reduces. I like that. Somebody is saying, is that why camphor reduces? Yes, that is why camphor reduces. It turns to gas immediately. It does not melt. It does not turn to liquid. It turns to gas. So camphor is one of such solids, and we have other solids, some other solids that behaves like that. Okay, now the process of going from gas to liquid or from liquid to solid is cooling. It's cooling. Okay. Somebody say, I thought iodine was liquid. No, iodine is not a liquid. Iodine is a solid. That iodine you see in chemists, I've written them out already. Can't you see my board? That iodine in solid, in liquid, has already been dissolved in spirit. That's why it looks like liquid, but iodine is not a liquid. Iodine is not a liquid. Choma Obuehi, God bless you. Air freshener. Those solid air freshener is also another example. Those solid air fresheners are another example. They turn from solid straight to gas. They don't melt. They go from solid to gas straight. Oh, I love this. This is beautiful. Choma, thanks for that. Okay. I thought you guys can see my board. I wrote it down. Okay, you didn't see my board. All these people that are just coming, you guys want to drag us back. So I'm going to show it one more time, but this time around I need you guys to just screenshot it, you know. Air freshener goes from solid to gas. Air freshener, that's why that solid air freshener keeps reducing. The solid air freshener keeps reducing. The solid air freshener keeps reducing. And that process is called sublimation. This is the process. This is where we started. So those of you that want to snap it, you can quickly take a screenshot. Then this. Somebody said if you cool camphor it will turn back to solid. Yes, if the right conditions are met. If you cool camphor it will turn back to solid if the right conditions are met. Just note that. Okay. Let me move forward because of time. Okay. So the next thing we want to talk about is physical and chemical changes. Okay, so before I continue, please, if you miss any part of this class, the video will be made available for you to watch it again. So go back and watch it, okay? If for any reason you came late. So please. So now I want you to follow me from this point. Physical and chemical changes. Don't drag the class back. Now, I want to talk about physical and chemical changes. Okay, so matter undergoes two kinds of changes. Matter undergoes two kinds of changes. Listen again. Matter undergoes two kinds of changes. Don't worry, any other question, ask it later, so that we can move on. But if you want to cool now, just put it in a fridge. Scientists know how to create a cool environment. That's not a problem. So matter undergoes two types of changes. The first kind of change is called a physical change. The second kind of change is called a chemical change. Matter undergoes two kinds of changes. We have physical change and we have chemical change. Now I want to define the difference between the two. Now listen. I'm writing for physical change. A physical change is one that is easily reversible. A physical change is one that is easily reversible and in which no new substance is formed. Okay, so we say that a physical change is one that is easily reversible and no new substance is formed. That is a physical change. Let me give you some examples of physical change. If you put water, for example, in a fridge, like in a freezer, after some time you will notice that that water will turn to ice, which is a solid. If I bring out that solid from the freezer and I place that solid on a table, what you will notice is that that solid will melt. What does that mean? It means that the process is reversible. That means I take the liquid, I put it in a freezer, it turned to It turned to solid. Then I bring out the solid and put it on the table. The solid will melt back to become a liquid. That process is physical. That process is reversible, and that is why it is called a physical change. That is why it is called a physical change. You guys should wait. All of these questions I'm teaching, so just follow. All of this is called physical change. So let me give you types of physical change. The first type of physical change, example of physical changes. Listen. Example of physical changes. Please make sure you are writing. Number 1, all change of state of matter is a physical change. So one of the example of a physical change is all the change of state of matter. What are they? Freezing, melting, sublimation, which other example? Let's say we say condensation, vaporization, deposition. All the change of state of matter are reversible. They are all physical changes. All of them are physical change. And the reason why they are physical change is because they are reversible. Please listen and listen well. I mentioned something about, I gave an example of ice. You know, you can melt ice. The water you get can also be frozen to get back ice. You can evaporate water. You can make water evaporate, but you can get back that water. You can condense it back. The process is reversible. If you change from solid to liquid, you can also change from liquid to solid. So that kind of change is a physical change. Now, other examples of physical change. Number 2. I think instead of you guys to write, I think it's better you listen. Some of the questions you are asking are things that you know I'm going to mention. So why not listen? The second type of physical change is something like dissolution, dissolving salt in water. If you dissolve a salt in water, you can get back your salt too. That's a physical change. Some of you know that, you will agree with me that if you put salt in water or you put sugar in water, you know everything will dissolve. The salt will dissolve in water. The sugar will dissolve in water. But you can get it back. The next topic I will be teaching you guys is to show you guys how to get these things back. You can get it back. You can get your salt back. You can get the sugar back. So it is a reversible process. A very important thing for you to note. There are many other examples. Another example, number 3, is what we call separation of mixtures. Separation of mixtures is another example of a physical change. Yes, when you mix two things together, you can separate them. You can reverse the process. For example, I can mix sand and water. I can separate it. If I put sand and I put water and I turn it, no matter how I turn it, I can separate it. What that means is that is a physical change, because that kind of change is reversible. If I mix sugar and sand, I can separate it. There is a way to, okay, let me ask a question. Who here can tell me, if I have sugar and sand mixed together, how can I separate it? Can you think? Think of how you think we can separate sugar from sand. Sugar and sand. You know, sugar is a solid, sand is a solid. So think, how do you think we can separate sugar from sand? Okay, I like what I'm saying. It means that some of you have an understanding. If I have sugar mixed with sand, the best way to separate it is that first of all, I will add water. I will put water. Sand cannot dissolve in water, but sugar can dissolve in water. If I add water and I mix it, all the sugar will dissolve in sand. Then I will use filter paper to separate it, filter it. Then I can use any method, maybe evaporation or crystallization, to get back my sugar. So it is possible for you to separate sand, a mixture of sand and sugar. So separation of mixtures is also an example of a physical change. Don't worry about the process. That's the next topic we'll enter. Separation of mixtures is a topic. We are going to discuss that topic. I hope I am making sense. I hope I'm making sense. You can write that. Number 4 is what we call heating. Okay, good. Good. So please, if you don't understand anything, just type I don't understand so that I can go back. Okay? So another example of a physical change that I just wrote here now is that zinc oxide. There is a substance called zinc oxide. If you heat it, nothing changes. It just turns to yellow. Then when you cool it, it will turn back to its original color, which is white. That is a physical change. Nothing happened, just a change in color. When you heat it, it becomes yellow. When you leave it, it turns back to white. That kind of change is a physical change. So this and many more is telling us something about physical change. Okay, very important. Two things makes up a physical change. Number one, no new substance is formed. Then number two, it is reversible. Okay, that is what makes physical change. And I think I have given you number 4. I've given you 4 examples. Okay, so now don't worry about zinc oxide. It's just there are some substances that when you heat them, their color will change. Only their color will change. If you remove the heat, they will turn back to their original color. That's a physical change. Some substances are like that. An example of those substances is zinc oxide. Okay, that's very important. And let me think. I'm trying to think if there is anything around us that behaves like that. There are some things that when you heat them, when you put fire, they will change color. But when you remove the fire, they will return back to the original color. Those kind of substances, that kind of change is a physical change. An example is zinc oxide. Just know that for now, right? Remember, this is foundational. As we continue, you start knowing chemistry better. So that leads us to the next thing. So the next thing I want to talk about is chemical changes. So a chemical change is one that is not easily reversible and a new substance is formed. Okay, so a chemical change is one that is not easily reversible and a new substance is formed. You cannot reverse them. So let me say this. Whenever you combine two things together and they react, how you will know that two things react? Some of you must have heard of chemical reacting. When two things react, you can never get it back. Let me give you a good example. In your house, when you take yam to cook, or beans or rice, and you cook it, when you cook it and it boils, can you get back your raw yam? Can anybody get back your raw yam or your raw rice back or your raw beans back? I need your response. Can you get back your raw rice or raw beans or raw yam? Litmus paper has nothing to do with what we are talking about, okay? So please leave litmus paper. Answer my question. When you cook rice or cook beans or cook yam, can you get back your raw rice from it? Somebody say you can dry it. Is it going to be original? Yeah, somebody say chameleon. Yeah, for physical change, that's correct. There is no way. It's not possible. It's not possible. You can't get it back. You can't get the raw form back. The reason is because whenever you cook food, the kind of change that happens when you cook food is a chemical change. The kind of change that happens when you cook food is a chemical change, because you can't reverse the process. You can't get it back. Okay? It is not possible for you to get it back. Now, there are many other instances. I want to tell you a story, and you are going to tell me if this is reversible. There are many instances. Let me tell you a story. Now, two girls were very, very close friends. Very, very close friends. They were best friends. Now, but something happened that whenever these two girls are working together, boys usually, okay, so went to the market and bought acid. In the process of buying acid, when they were now together, she now poured the acid on the friend's face, and the friend's face got damaged. The friend's face was damaged. You know, it was a very sad story. A very, very sad story. Now, let me ask you a question. That change on the girl's face, is it a physical change or a chemical change? I leave that to you. So I'll be waiting for your response. Based on my story, is that change a physical change or a chemical change? Pouring acid on her friend's face and the face disfigured, is that a physical change or a chemical change? I'm waiting. It's not going well, but it's better here. Very good. I like the responses that I'm getting. That kind of change is not reversible. Now, I have the story of a friend who was cooking, and there was an explosion and all her body got burnt. That is another example of a chemical change. It cannot be reversed. Many of the people that we see like that, their body remains damaged for a very long time until they die. There is nothing you can't say later is going to be. Even plastic surgery has not worked for those things. I want you to go and do your research and know and understand what I'm talking about. So let me give you examples of chemical changes because of time. So write it. Number 1. Number 2. Burning of paper. Number 3. Changes in electrochemical cell. Number 4. Dissolution of metal in an acid. Number 5. Number 5, decay. When you say something decay or sours. Number 6, fermentation. Fermentation is the process of making alcohol. Okay. Number 7, there is something we call slaking of lime. That is also a chemical change. Okay, I mentioned changes in electrochemical cell. Number 5, you can also say, okay, number 8. I think this is enough. Somebody say not a real story. You need to grow up. You are still young. Don't worry, be coming up. All the stories I told you are real life stories, are people I know. Okay. These are examples of chemical changes. Very, very important. Okay. Number 4 is called dissolution of metal in acid. There are many of them. Let's say reaction of acid and base. And so on and so forth. So these are the much I can pen down now. You can research some of them. Yes, growth is a process of chemical change. Okay, the first one I mentioned is burning of wood, to burn wood. The second one is burning of paper, when you burn paper, normal paper. The third one is changes in electrochemical cell. An example of electrochemical cell is battery, car battery, or battery, your finger battery. You know, those batteries you used to charge your, you used to put in your remotes, even and all of that. All kinds of batteries are electrochemical cell, and the kind of change is called chemical change. Dissolution of metal in an acid. When you dissolve a metal in an acid, it reacts completely. Even rusting, yes. I just remembered rusting. Rusting of iron is also a chemical change. Okay. So, decay. When you say a food has decayed, you know, or maybe, you know, I'm sure everybody here knows what decay is. When a rat dies, you leave it outside for some time, it begins to decay, it begins to smell like a body, a dead body. When you put a dead body, that's why they always store a dead body in a mortuary, and there are some chemicals they put that dead body in so that that dead body will not decay, because it is going to decay and it will start smelling. Okay. Then fermentation is the process of making alcohol. If you have ever heard of alcohol, alcoholic drink, that is fermentation. That process of making alcohol, the one that you shack. You know, some people take alcohol. You know, I don't take alcohol. Okay, that is fermentation. Okay, and it is a chemical process. Then slaking of lime. Now, there is something we call lime. This is not something you may understand now, but slaking of lime is, we call it adding of water to quicklime. It reacts to give you something like this. Some of you may not understand this. Slaking of lime is also called adding water to quicklime. You know, there are some substances that react with water. When they combine with water, it produces something new, something different. Okay, very important, something different. And you have reactions of acid and bases, and you have and you have rusting of iron. Yes, cassava can ferment. Any carbohydrate can ferment. Cassava, rice, millet, maize, all of them can be used to produce alcohol. That process is called fermentation, and the type of change is a chemical change because you cannot reverse it. You can't get back your rice from alcohol. You cannot get back your cassava. It's a chemical change. A new substance is formed. So what makes a chemical change is that a new substance is formed and it is not easily reversible. Okay, so please let me know if you understand that. Do you understand? If you understand, say yes, I understand. Okay, so please, I want to beg you, this class is not for arguments. Just follow what we are saying, right? Some questions you can ask them later. So the next thing I want to talk about is what we call good. The next thing I want to talk about is what we call physical and chemical properties. Physical and chemical properties. Okay? So after this, when they ask you what is the physical property of something, you know what it means. And when they ask you what is the chemical property of something, you know what it means. So that's what I want to explain now. Okay? For example, now please listen. For example, let me start with physical properties. Now, physical properties, first of all, what is properties? Properties, I'm sure you know what properties is. Properties simply means, the features or characteristics of a thing, what you can observe about that thing. Okay? So, if I say a physical property, it means a property that I can understand with my five senses. I can see it, I can hear it, I can feel it, I can taste it. These are physical properties. For example, if I see you now, I see somebody. Okay, from what you can see in the picture, you can say some things about my face. Some of you can say he has a big head. That's a physical property. Some of you can say he has beers. That's a physical property. Okay? So, anything that you can feel, it can be taste, it can be color, it can be sound, it can be anything. Anything you can feel is a physical property. That is very important for you to note. Okay? So, I want to write that down. So physical properties are properties that are associated with physical changes. So physical properties are properties that are associated with physical changes. There are properties that are associated with physical changes. So if I want to say, okay, tell me about Solomon, you will begin to talk. Or let me use a compound. Let me say, I tell you, tell me about salt. There are many things many of you can say about salt. One of the things that will come to your mind is the color. You say the color of salt is white because of its white. Another thing that can come to your mind is taste. It tastes salty, right? Yeah. Another thing that can come to your mind is that salt may be brittle. We call it brittle. There are other physical properties. So we can also mention something like solubility. Solubility means, is it soluble in water? Density. We can talk about the mass. You can talk about the size. You can talk about the volume. Kai, you see somebody, you say, Kai, the person is too voluminous, it's too big. Or you talk about something, it is big. That's a physical property. You can see it, you can sense it, you can feel it. You talk about smell. Now, smell or odor. You talk about malleability. Malleability is a special property of a metal. Malleability simply means the ability to bend. Something you can bend the metal. For example, many wood is not malleable. Some wood, once you bend it, it will break. Some of them, okay? But some others is malleable. Now, actually, wood is not malleable. Malleability simply means when you beat something into shape, you can make it any shape that you want. That's what it means to be malleable. And wood cannot really be done like that. Then we have, apart from malleability, we have ductility, the ability to be drawn into wires. We have, that means ductility. You ask yourself, can that thing be made to be like wire? Wire, you use to wire your house. Anything that you can use to wire your house is ductile. Example is metals. Metals generally are ductile. Okay. So the next thing is we have ductility. We have there are many of them. Physical changes. Photosynthesis is a chemical change. Photosynthesis is a chemical change. Choma, you may need to look back. You may need to go back to the video because I've been talking. Photosynthesis is a chemical change, okay, not property. Okay, you can also call it a property, a chemical property. Like if they ask you what is one of the chemical properties of a plant, you can say plants can undergo photosynthesis. Something like that. Okay, so all of these things that I've written, I want to believe that it clarifies the issue of physical properties. You ask yourself, what is the color of that thing? What is the taste? How does it taste? This is a physical property. Is it brittle? Brittle means, can it easily break? Can it break? That's brittle. Is it soluble in water? For example, now, one of the physical property of a salt is that salt is soluble in water. If I put it in water, it's going to dissolve in water. That's a physical property. Then density. Density talks about how heavy. Is it heavy or is it light? Is that stuff heavy or is it light? Okay, that is a physical property. Then mass means how big is it? How mass and density are alike. That is very, very good. Okay, I believe that you guys are following. I'm going to wait for your comments. Are you following? Do you understand this? Are you following? Do you understand this? The issue of physical properties. Choma, that was a mistake. Okay, good. So, just like I mentioned, when you see something, whatever brittle means the ability to break. You know, there are some solid that you can bend, but some solid, if you try to bend them, they will break. Those kind of solids are brittle. Those ones that can easily break, they are brittle. And that is it for physical changes. So physical changes are things that make sense to your five senses, are things that you can observe using your five senses. You can see it, color. You can smell it, the odor. You can taste it, the taste. You can hear sound. Sound is also a physical property. Okay, how does it sound? Okay, there is also, let me write it. There is one that is called sonorous. Sonorosity. Now, if you check when you say something is sounding sonorous, if you check when you beat, let's say you beat a metal stainless plate, you know it gives this sound, this clinging sound. That clinging sound is what we call sonorosity. Is sonorous. It gives that sonorous sound. It's metal. Clang, 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 you know, something like that. Very, 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 very important. So that now leads us to just few metals are brittle, but not all. Most metals are not brittle, but some are brittle. Most metals are not brittle, but some are brittle. Okay, so that leads us to chemical properties. So chemical property is a property of a substance that leads to the formation of a new substance. Yes, pig iron is brittle. Yeah, it can easily break. But please, let's focus on what this class is, right? So, chemical property is a property of a substance that leads to the formation of a new substance. Okay, if you want to mention chemical property, these are the questions you will ask. For example, example of question you ask is, for example, does it react with water? This is a chemical property. You can ask, does it react with acid? You can see the word react. Anytime you are talking of chemical properties, you must call react, because a new substance is formed. Anytime two things come together to produce a new substance, it means that they have reacted. So the word react is used in pari passu with chemical properties, or with chemical properties. So you ask yourself a question, does it react with water? Does it react with acid? Does it react with air? You know, some substance react with air. Let me even say this. There are okay, so there are some things. I wish I can. Okay, how many of you know knockout? Maybe in Lagos, I grew up in Lagos, they call it banga, knockout. That's when you put fire on it, it explodes. That explosion is chemical explosion, is a chemical property. So if somebody asks you, what is the property of banga? You say, that thing, once you add fire and it catches with air, it's going to explode. That is a chemical property. So you ask questions like, what does it react with? Does it react with water? Does it react with acid? Does it react with air? You know? And so on and so forth. That's very, 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 very important. Okay? That is it for chemical properties. So in today's class, I've been able to give you the difference between what is it called now? We've been able to see matter, the definition of matter, the change of state of matter, the processes involved in the change of state of matter. We have been able to see physical and chemical changes, and we have been able to see physical and chemical property. I am glad to announce to you that we have come to the end of the second chapter in chemistry. So congratulations to you guys, especially the freshers, those of you that are new to sciences. Congratulations. We have come to the end of chapter 2. So this is what we usually do. We add people, okay? We send questions based on what we have learned in today's class. I'm going to send certain questions. So you are going to practice those questions. Okay? You are going to write the questions, answer the questions, then, of course, I will get the reply of your answers. And that is it. Okay, I want to give you a few minutes. If you have questions, you can write the questions. If you have something to say about the class, you can say it right now. If if whatever it is, whatever comment you want to make about the class, you can make it. If you have a question, you can ask. I'll be here to answer you, maybe within the next 5 minutes. About 50. So. Okay, so I'm waiting. Any questions for me? So that means you are telling me that you all understand very well. Yes, does it react with fire? Does it explode when you heat it? That's also a chemical property. Lillian, that's correct. Please, plasma, forget about plasma, please. I beg you. Oh, somebody say, why does salt turn to a liquid after it falls on the ground and stays for some period of time? Okay, not all salt though. Some salt does like that. That property is called hygroscopy, or what we call deliquescence. Is the ability to absorb water from the environment. Some salts have the ability to absorb water from the environment and they turn liquid. It's a special property that is called hygroscopy. Okpeyemi says, I love your class. Thank you very much. Thank you. I'm glad you do. Is it all chemical changes that cannot be reversed? Yes, all chemical changes cannot be reversed, but there are some things, some chemical changes can be reversed, but that's a topic on its own. When you get to, when we get deeper into chemistry, some reactions are reversible, but they are not they are not physical changes, they are chemical changes. Please, let's avoid plasma for now, okay? I know some of you are curious. Somebody say, why does salt kill animal? When you see your biology teacher, you ask him. But when you see a salt killing animals like earthworm, is because salt attracts water. So it removes all the water in the earthworm. That causes the earthworm to die. So that's for that one. So we have a whole lot to learn together. And I'm glad some of you are understanding it. Yeah, Isaac Mwabeke, thank you for teaching you. Thank you. Kunle, an interesting class. Thank you very much. Milios, I love your class. Thank you very much. No, physical change cannot be permanent. It will be reversible. It can't be permanent. As long as it's a physical change, then it is reversible. Maureen. Okay, I think you guys have finished asking your questions. I think we can call it a day here. Salt is not an acid. Don't worry, there is a topic. When we get to chapter 5 or chapter 6, you will see acid, bases, and salt. Just calm down, we'll get there. Choma says, I love this class. Thank you. Yeah, does it react with base? That's a chemical change. I like that. You guys are wonderful. Yeah, does it react with fire? Does it react with heat? Yeah. You're welcome, Lillian. Thank you. The class was interesting. Ugochukwu, thank you. Thank you. Okay, so I'm going to stop here. See you in our next class. I think I have done my bit here. I appreciate you guys. So tomorrow's class is going to be English. So your English teacher will be with you guys tomorrow. Okay, so bye. Bye. A very educative class. Let me stop streaming.